Hello guys, today we're going to be looking at the CH32V203 and how to implement it in a hairdryer system. So I'm going to go and break down a hairdryer and we can see how we are using CH32V203 and all its advanced motor control functions to actually make a product and a final product. So if you haven't watched, you can check out my previous video on using the advanced timer with the CH32V203. So I'm going to begin now. So we're going to be looking at some of the key components inside the hairdryer, as well as walking you through the design process and how each component operates. So the CH32V203 is ideal for this type of product. So the first element we're going to see is the thyristor, which is a 4-layer 3-junction PNPN semiconductor device, and this is usually used as an electrical switch for high power operations. So in the hairdryer, we use the thyristor as a switch to turn on and off the coils for heating the air. So if we need to switch to hot air, then an electric coil consumes a lot of power, so we need something that can operate as a switch for such high power devices, and that is the thyristor. And then for the MCU, we're using the CH32V203, which is an advanced timer, which is ideal for such a use case. And we want to use the advanced timer to create a PWM system and also get the complementary output as well, and plus access to deadband time for tuning the advanced timer. And then we have the MOS and the MOS driver to help MOSFETs to maximize turn on and turn off time. Driver circuits are needed. That's because if we use the MCU itself, there are slight delays and complications, especially for high power devices like the one we are using. So we use the driver to make sure that the MOSFETs we are using to drive the motor turn on and off extremely fast. And then we also have an optocoupler. In this one, it's used mainly for low voltage control, of circuits. So the main advantage is that they have extremely high electrical isolation, as you'll be using light to control AC voltages, currents, and power. And then we do have a 3.3 volt LDO, and this is mainly for supplying a stable voltage, as through conversions from AC and the transforming of the power source, this can result in unstable power. So by using an LDO, we can guarantee that the output is exactly what we want. Compared to other voltage regulators, this one includes no switching noise and has a much smaller footprint as well. And then we have the AC to DC converter. So from 220 volts AC to 310 volts DC. So the main job of this circuit is to convert the AC we are getting from the main power supply, then direct it to the motor as DC voltage, acting as a voltage regulator. Okay, so this is a teardown of the head dryer. And so this is the power on, and then we have 2 stages, high and low velocity. And this is to change the operation mode. So it can either be hot, cold, or warm, and then you can choose the speed from low to high. So for example, if we were to turn this on, then as you can see right now, it's operating in hot, and then because the temperature is at its highest. And then we can also increase the volume of oxygen, but when we press this button, we switch between cold air at 30 degrees warm air at 50 degrees, and then lastly hot air at 70 degrees. Okay, so in this video I'm going to be breaking down this hairdryer. So I'm going to start off by twisting the back, that way we can get access and unscrew the handle. Inside the handle is where the motor resides, and we're going to access this motor, and I'm going to show you how it works. So it's an FOC motor. And once we are done opening, I'm going to show you how to operate and how to work with the motor as well. As you know, at WCH, all of our MCUs, they support a wide range of motor protocols. So you can contact us and we can help you develop a prototype solution that is specific to your needs. Okay, in order to detach the handle, we need to pop out the buttons, which is what I'm doing now. So that's one for mode selection, and then this one is that one is for power, and then this one is for mode selection. And then we need to remove the screwdrivers that hold the handle and the device. Okay, now we can get access to the motor by removing this top part. Okay, with that you can now get access to the motor, which I'm going to show you. And then we're going to separate the handle and the head of the hairdryer. That way we can begin to show you what's inside and how you can get access to the MCU. Okay, now the next part is we're going to open up the cap in order to expose the MCU and the PCB. So as you can see, for the first time we are now seeing what's inside the hairdryer, and we're just going to separate these two pins, one for connecting to display and the other one for connecting to our main MCU controlling the hairdryer. And then I'm just going to unscrew these holding screws, and then we're going to see what's inside the MCU, what's inside the PCB, and how each component is being utilized. Okay, so now in order to separate the PCB from the hairdryer, we're going to solder off the last connecting pins, and then we're going to get access. So all these pins right here, they are soldered. So we're going to remove all the soldered pins and get direct access to the hairdryer's PCB and look inside. Okay, the next part is we are going to be solder off the remaining components. That way we can get access to the PCB. And we're going to take our solder iron and we're going to slowly detach all soldered components, mainly the connection points between the handle and the PCB. As you can see, as we solder off more and more components, the PCB starts to detach slowly. Okay, now that we've soldered off all components, we can now begin to analyze the MCU and the PCB. Okay, now we're going to break into the handle and we're going to see the motor, the FOC motor, which is the one driving this fan. Okay, so this is the intake pipe, and then if we open, now we can look at the control buttons, the green one being the switch, and then the black one being a lever to control the 3 stages of operation. And then we have the switch to change the mode. Okay, and then so this is the motor, this is the one that powers our hairdryer. And as you can see, it's encased in a rubber closing. Now, the aim of the rubber is to stabilize. And as you can see, these are the 3 inputs to our motor. And then this rubber, its main job is to stabilize the motor. That way it doesn't shake vigorously, and it makes sure that it's properly fully in contact with the walls of the handle. The next part is the PCB. So this one is the one which controls the lights. So the display panel is controlled by this PCB, and as you can see, this MCU is the one which is controlling how the LEDs turn on, and we connect it to our PCB, to our other PCB via an external bus. Okay, so now we're going to look at the PCB, and we're going to be looking at the main components. So as you can see, the PCB has the standard main components you would expect. A capacitor, this is a thyristor, it's for controlling temperature of the coil, and these inductors and capacitors, they are for voltage regulation. On the left, you can see the MOS drivers, the 3 MOS drivers, and right underneath this capacitor, we are going to see the MCU. So I'm going to place it down and I'm going to zoom in a little so that you can have a much clearer view of how the board is set up. So as you can see, these are our MOSFETs, and the MCU on top of them, that 8-pin MCU, is the MOSFET driver. Now if we flip it over, we still have our MOSFETs here and the driver as well. And then this is the pin bus that we connect to our LED controller. Now under this capacitor is where we have the main MCU. So I'm just going to open it. That way we can see what's under the capacitor. Okay, as you can see, under the capacitor is our main MCU, this one, the CH32V203, and then LDO right on top of it. Okay, so the CH32V203, in this case G8R6, comes in a QSOP28 package with one advanced timer. So it's the advanced timer that we mostly use for motor control at this level. And if you need any help implementing motor-based solutions or any product solutions in general, you can contact WCH and they can assist you on how to better implement your product using their MCUs. So they can help you come up with a proper solution. If we pause to analyze here, we can see that this is the SOP28 package of the MCU, and we're going to look at the data sheet a little bit in order to really see what's being placed and implemented. Now, if you have any questions about using CH32V203 and motor-based applications, then you can reach out to Patrick on Twitter, or you can leave a comment section or send a private message. You will reply instantly. So I hope you saw a practical application of the motor controls for WCH MCUs and how we can help you achieve complete product protocol and design using even the most advanced motor functions.